How do orbital maneuvers fight atmospheric drag in LEO? Imagine a satellite gliding through space, but just above the Earth's surface, where the air is thin but still pushes back. That push is called atmospheric drag, and it slowly pulls the satellite down. Over time, this causes the satellite to lose altitude and drift away from its intended path. To keep satellites in the right spot, space agencies use special tricks called orbital maneuvers. These maneuvers are like a car hitting the gas pedal to go faster and stay on course. Satellites in low Earth orbit, which is below about 2,000 kilometers above the surface, experience this drag because of the thin atmosphere. Even though the air is much thinner than at ground level, it still creates resistance when the satellite zips through at speeds of around 7 to 8 kilometers per second. The faster the satellite moves, the more drag it feels. The density of the atmosphere can change with solar activity. When the sun is active, it heats and expands the atmosphere, making drag stronger. During quiet solar periods, the atmosphere shrinks and drag lessens. To fight this, satellites perform what are called orbit-raising maneuvers or reboosts. These involve firing onboard thrusters to give the satellite a quick push. This boost increases the satellite's velocity and altitude, counteracting the energy lost to drag. These maneuvers are planned carefully because they use fuel, which is limited. During high solar activity, satellites might need these boosts every few weeks. When solar activity is low, they might only need them a few times a year. Another clever method is called differential drag. Instead of firing thrusters, the satellite changes its orientation or shape to control how much drag it experiences. For example, by tilting solar panels or adjusting surfaces, the satellite can increase or decrease drag intentionally. This helps it fine-tune its position without using fuel. It's especially useful for satellite groups that need to stay in formation or avoid collisions. The effectiveness of these maneuvers depends on several things. The altitude matters because the higher the orbit, the less drag there is. The shape and size of the satellite also play a role. Larger surface areas like solar arrays catch more air, making differential drag more effective. During periods of high solar activity, satellites need to perform these maneuvers more often to stay in their proper orbits. In short, orbital maneuvers fight atmospheric drag by either giving the satellite a push with thrusters or by changing how much air resistance it faces. Both methods help keep satellites in the right place, ensuring they can do their jobs, whether it's taking pictures, relaying signals, or gathering data. These techniques are vital for maintaining satellite health and longevity in the challenging environment of low Earth orbit.